All right, when solving a linear equation with a bunch of fractions like that, one great method is to clear the fractions, and we'll show that now. The first thing I'm going to do is distribute the parentheses on the right-hand side of this equation. So I have 4 gets multiplied by 2/3, which gives us 8/3, x, and then minus 4 times 3 is 12. What I'm going to first do here is I'm going to write 12 as 12 over 1 because I want to think of each of these terms in fractional form. Now what I'm going to do is I'm going to multiply this whole equation, or each term in the equation, by the least common denominator. In this case, the least common denominator would be 12. As you'll see, I've written in this next line, when you multiply the equation by 12, what you're actually doing is multiplying each term by 12. The reason that we do this and why we use the least common denominator is because of the result here. So 12 times 1/4 is 3. So this first term becomes 3x. This next term is 12 times 1/3, and that becomes 4. The next term, 12 times 8/3, we'll kind of go into more detail on this just so make it more obvious. We think of this 12 as a 12 over 1. We can do some cross canceling here. For instance, the 3 and the 12, I can divide the factor of 3 between those to get a 4 up here in the numerator and a 1 in the denominator. And then I'm just going to multiply these fractions across. It's 4 times 8 is 32, and then 1 times 1 is 1. So that fraction will become 32 over 1, or more usefully, it's just 32. And then we have the x. And this last statement is 12 times 12, which is 144. So the whole purpose of multiplying this equation by 12, and specifically the least common denominator, was because of what occurs here. We now have an equivalent equation that doesn't have any fractions, and that occurred because we use this number that's a common denominator and the canceling that occurs. All right, so we've cleared fractions. Now we need to do is solve this equation like we do with any other linear equation. The first thing I'm going to do is I'm going to isolate the variable. I'll subtract 32x from both sides, getting minus 29x plus 4 equals negative 144. I'll now subtract 4 from both sides. By 4, I get negative 29x equals negative 148. And then I'm going to divide everything by negative 29 to isolate my x, to get the x equals 148, excuse me, over 29. Those negatives here had canceled each other, so I don't need those. It says if I can, but I know that 29 is a prime number, and therefore, unless 29 goes into 148, this cannot be reduced.